Hello everyone, welcome back to JDCodebase. Today is day 8 of our LeetCode 75 study plan series, and today we are solving LeetCode number 334, increasing triplet subsequence. This problem looks simple at first, but the optimized solution is actually very smart and is asked a lot in the interviews. So today we will understand the problem, the logic behind the optimal approach, then we will code it step by step in the JavaScript. So let's start and read the problem statement. Given an integer array nums, return the true if there exists a triple of indices a, I, j, k such that I is smaller than j, j is smaller than k, and also nums of I value is smaller than nums of j, nums of j is smaller than nums of k. If no such indices exist, then return the false. Let me simplify it. Given integer array nums, I have this in the input. I get an integer array nums like 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, 2, 1, 5, 0, 4, 6. We have to return true if there exist three indices I, j, k such that I is smaller than j, j is smaller than k, and their values like nums of I is smaller than nums of j, nums of j value is nums of k. So if no such triplet exists, return the false. In simple word, if I say, we just need to check if there are three numbers in the increasing order or not. Like I have this 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I have to just check. We have to return the true. Why? Because 1 is smaller than 2, 2 is smaller than 3, and their indices are also in this pattern 0 index, 1 index, 2 index. So another example, if I say 5, 4, 3, 2, 1, and for that we have to return the false because everything is decreasing. 5 is not smaller than 4, 4 is not smaller than 3, and their indices are the smaller but their values are not. So now let's think about the best approach. A brute force approach is a solution like we would use the three loops, like one loop for the first index, second loop for the second value, third loop for the third value, and check whether these are the means nested loops big of n squared, big of n cube time complexity, and which is very slow. Even big of n square is not idle, and this pattern is like triple for loop, triple nested for loop is a very complicated time complexity, very high complexity. That's where this smart greedy approach comes. We only track the two values, first one and the second one. The smallest number seen so far, that is the first. The second smallest number seen after that, that is the second. And at the beginning means we just define by the infinity value. So let's start with the code here. Let first value is the infinity, means it is too high for this. Let second value again infinity. Now start a for loop for let num of nums, a JavaScript for of loop. If num value is smaller than equal to first, then we have to make it to the first value is equal to num. Now I just update the first value. Else if num value is smaller than equal to the second value, then second value is equal to num. And else if all num value is greater than first, num value is greater than second, then just return the true here. Means it passed it both the condition, means we get the first value, we get the second value. Now this is the third value I want and I get it. So return the true at this moment and return the false if nothing found in this. So now let's quickly dry run for this. I have a array called 2, 1, 5, 0, 4, 6. I have this random shuffle array, right? First is infinity. I just write infinity, and second value is also infinity. Now, as I start start the loop, I get the 2. Now 2 is smaller than first. Yes, infinity is too high, and 2 is too very slow, very small value. So we have to just update the value of first by the 2, and second value still infinity. Right? Now I get the 1. 1 is smaller than 2. No. Yes, 1 is smaller than 2. Yes. So I just update the value of first by 1, and second value again infinity. I did not get to chance to check the second value. Now I get the 5. 5 is greater than 1. No. Oh, 5 is, oh sorry, smaller than 1. No. So I check 5 is smaller than infinity because second value is the infinity. Yes, it is. So for that, first is still 1, second is now 5. Not 4, it's 5. Now I get the 0 value. Now this time 0 is smaller than 1. No, it is not smaller than 1. 1 is greater than 0. Now in the second case, 0 is smaller than this 5. Sorry, I have to check the smaller one. So 0 is smaller than 1. Yes, it is. So I have to just update the value first by the 0, and second is this still 5. Now I get the 4. 4 is smaller than 0. No. 4 is smaller than 5. Yes. So first is the 0, second is the 4 now. Now I get the 6, and last 6 is the smaller than 0. No. Second is the smaller than 0. 4 is the smaller than 6 is smaller than 0. No. So in the last case, I have to return the true. Why? Because I get the 6. Now 6 is the bigger than the both first and second, and first value I already get the 0, second value I already get the 4, and 6 is the third number. So 6 is bigger than both first and second. That means 0 is smaller than 4, 4 is smaller than 6, and triplet found, return true. That's it. And let me run the solution for you. Let me comment it first. Yes, it's done. Let's try to submit the solution. Yes, it passed all the 86 test cases, and that's it. It's a very simple one. You understand the pattern right here, and once you understand like how greedy thinking can reduce big of n cube, if you may write the brute force approach. First you write the like for let I equal to 0, I smaller than nums dot length I plus plus, and after that wait a second, this one is for the first number. I get for let j equal to I plus 1. J is smaller than nums dot length j plus plus, because I have to also check whether I is always smaller than means j is smaller than k. For that case, again new for loop, for let k equal to j plus 1, and k is smaller than nums dot length and k plus plus. Now see, you have to check in the 3 for loops in the big of n square time complexity, that is too high, and our solution says big of n time complexity, only a single for loop run. So how to track minimum value smartly? By using the means smaller than equal to is why. If you notice here, I just write it smaller than equal to. Why I don't means why I write here the equal value? Because if for the handle the duplicate, like if I have the 2 means if I had the again the 1 here, then what I can do. So for that value, for that case, I write here the equal situation, equal case. And how interview question often test logic more than the code. This is the one of the those problem where the code is short but thinking is the real challenge for you. Like this one, for if how much line of code, like 1 2 3 4 5 6 7 8 9, just a for loop of this 3 if else condition, nothing else. But the thinking is the real challenge here, not the how you write the code. If this explanation help you, make sure to like the video, subscribe to JDCodebase, because we are solving the complete LeetCode 75 study plan step by step every single day. Also comment below, did you first think of the brute force, or were you able to reach this optimal solution directly? I will see you in the next video on the day 9.